Testing, testing. 1, 2, 3, 4, 5. Testing. Let's just copy the link and get that posted over here real quick. All right, and if we can just get, I don't know if anybody's here yet, if we can get some feedback in the chat on whether audio quality is good. Switch over to the fume hood and get that spun up real quick. Just cleaning off all the rough edges, and there we go. Get that rinsed off. And switch back to the bench shot. Got the board dried off. Clean the sandpaper up real quick before I start working on solder paste. Okay, so looks good. All the rough edges are gone and still a little bit wet. Get that dried off quick. Now over to the bench overview. We'll try this angle, see how that works, and build up the solder paste jig. This is a, let's try and get the camera, I can see a little bit more over here. This is a setup that I came up with a while back that is optimized for size rather than performance, but it is about all I could fit in my lab. A full-size stencil printer was not really an option. So it's these tiny little pieces of, just gonna try and hold this up to the camera and we'll see how that goes. Tiny little pieces of CNC'd aluminum that have a lip up here that the board sits in like this. And then on the other side is the corner and just string together with threaded rod. The results are definitely not as good as a dedicated stencil printer, but the whole thing breaks down and fits in this bin when I'm not using it. So we're just gonna go and string this together real quick. And again, the point of this stream is mostly just a test of a couple of camera angles, so I'm probably at some point gonna pause the assembly and just move around and test a few of the angles and just get some viewer feedback on if I should move any stuff around and if everything is generally going to be good when I actually start doing the real rework on it. And one more over here. And let's see. Probably are going to need a couple of these little plastic washers. At some point I want to either 3D print or machine some of these things in smaller sizes. Right now I've only got 1 centimeter and 5mm width, and I would like a few smaller options. check. And that looks good. And we're just going to run this until about 8 or so Pacific time, so around another 35 minutes, and however far I get. That's how much time I have this morning, and again, the point of this is mostly just to iron out some of the bugs in the AV setup before I start doing something more interesting, because it's been quite a while since I've done a stream out of this lab, and I figured there were probably going to be some rough edges. So now, string up the opposite side. And same deal, reverse this, and that goes out of here. I think I might actually want 2 of the shims on this one. Alright, so we're at there, and then we need 3 more. Spin this on, and yes, audio quality was one of my biggest concerns, given the amount of background noise in here is about 70 so dB ambient in here with all of the server cooling fans and everything, and I am trying to get this tiny little lapel mic to operate in these conditions, and a lot of the stuff I upload that's pre-recorded, I'm able to do some post-processing on to clean it up a little bit, and this new mic seems to actually do okay without post-processing. So that's definitely an improvement, although I may still mute the audio when I'm doing some of the work on the mill, because when I've got the dust collector, which is literally a shop vac running, I'm guessing I will probably still not be audible, although I don't think we're going to do any of that today. I may still just try and stream 30 seconds or so from the mill without the dust collector or the actual spindle running, just to again get some feedback from viewers on camera angles and generally whether everything seems good for when I start doing the actual rework. Right now, again, we are only going to be populating the back side of the board and doing some test angles. The front side is on hold because the DigiKey order with the last couple of parts is not coming in until Monday, and depending on work schedules and so on, I may or may not be able to actually do anything on Monday, so it may not be until a little bit later in the week that I can go and fully populate the board. The other thing is, again, I don't think there's going to be time to do it today, but in general, okay, audio, I do see one comment on audio low. All right, I will turn that up just a little bit and we'll see if that's a bit better. Anyway, so there is one challenge on the board. I'm not going to be able to show it on the camera here until I get under the microscope, but there is one challenge on the board that is under the BGA and is designed to be done before the BGA is populated. And so kind of one of the things I'm not entirely sure about regarding the whole concept of live streaming the project is seeing how well that's going to work as far as doing the project in a couple of phases with time in between them. What I may try doing is, just in the interests of camera friendliness, maybe doing one of the boards with just not populating, or not doing that one problem, and then maybe doing it on a separate blank board or something. All right, I can crank the audio up a little bit more, and we're down pretty much at maximum recording level here if I don't start adding any boost. I can also just try, see if maybe I zip up my shirt a little bit, it'll move the mic closer to my mouth. Is that a little bit better now? I can also play around with seeing if I can boost some of the gains elsewhere in the pipeline. Again, this is the sort of thing I'm used to correcting in post. I have not used this mic live before, so this is why we're doing this test. Okay, and we are now just about done. One more of those shims, I think, should do nicely for here. Perfect. And yep, string that on here. And again, you can see this is a pretty time-consuming process. You don't have to deal with this if you're using a regular stencil printer, but my lab also does not have the space. When I switch to one of the other angles, you can see how cramped the entire bay of the lab is. And you'll see there is absolutely no way in the world that would possibly have space for a full-size stencil printer. So, as with a lot of other cool toys on my shopping list, it was either improvise and get something less good or not have it. And so, yeah, this was what I went with. All right, so that's that. And always figuring out how many shims and stuff to use is always the hard part, and getting things in there is the easy part. All right, so we need 4 of the big ones and 1 of the small ones and 3 of the plastic ones. So 1, 2, 3, 4, and then 1 of the plastic, 2 of the plastic, and a nut, and 1 more plastic. Perfect. And then 1, 2, 3, and string this on here, and this here, and this here. And last one. And we should be good to go. And then get this on. All right, so we got the backside in, and then just tighten down a couple of these nuts so it sits in there a little bit more firmly, doesn't wobble around a bit. And good to go. Get that out of the way, and ready to go get the stencil aligned. Grab the solder paste, and we're going to be using the backside stencil, which goes here. I'm just going to grab some Kapton tape real quick. And also, while I'm in here, I got a bunch of components that I know I'm going to need. So I'm going to grab those bins while I'm at it. Whoops, we want the long shot of the bench. Let's do this one. Okay, so now we've got the stencil roughly in position. And get that taped down. That looks about where it needs to go. And yeah, there's a lot of networking here, but there's enough high bandwidth data moving around when you've got 2 thunderscopes running simultaneously and a bunch of VMs going to all different places. There's a lot of moving parts in here. And let's just tighten this a little bit more. Perfect. But yeah, especially once we start playing with like some of the Thunderscope Pro and Ultra, we'll have 40 gig Ethernet on them. And if I'm trying to stream that data to one of my other workstations around the lab, it is going to be important to have a backend that can keep up. I am probably going to be bumping up my core switch right now. I've only got 4 40 gig and no 100 gig and no 25 gig ports. So having the ability to do that and rather than just being 10 with a couple of 40 gig ports is going to be help. And Yeah, lab tour might happen at some point. It is a little tricky because I do day job work out of here as well, and so you'll notice a few of like the overhead shots from the security cameras are cropped because there are things just out of frame that I can't show. And so trying to pick times when I don't have anything interesting or, cover up everything from a customer that might be recognizable or whatever, it becomes a bit of a pain at times. But you'll see most of the fun stuff here. All right, so we've got solder paste on here, and then just squeegee that on and scrape things off there, and that looks good. And then peel our tape off. And print quality looks pretty decent. We will pop that under the microscope. See how that turns out. Yeah, print looks pretty much perfect here. All right, let's go clean up the stencil. And I'm going to leave the fixture out for when I populate the front side. That's not going to be on this stream because I don't have the time, but no sense taking it apart and putting it back together if I'm going to be using it again in a day or two. Okay, stencil is cleaned off, and we're not going to be using the front side stencil for now, so we're done with that. And then just get this fixture over here out of the way, and get the paste off of here. I always hate when I'm doing just one board and you end up wasting so much solder paste because there's not really a way to get it back in the syringe after squeezing it out, and it dries up and stuff over time. It always feels like a waste. All right, so IPA is done, and put the paste away. We're done with the stencil. Yes, I will be reflowing both sides. We're only going to have time to do one during this stream. Components do not fall off. The usual process for this, which is what I've always done, is reflow the backside first. The side with the least big components is generally considered the back, regardless of which way it's going to fit in the final system. And you populate those components first, and then reflow the board, and then apply paste on the front side, stuff it as normal, reflow it again, and during the second reflow cycle, the solder on the backside will liquefy. The parts will be held in place by surface tension as long as they're not too heavy. There is an equation that you can go look up that relates, it's an alloy-dependent surface tension constant to the mass of the component and the sum of the perimeters of the pads will let you calculate how much force there is holding the part on. If that is greater than, say, 4 times or whatever you want your safety margin to be the mass of the component, then it's not going to fall off. I've kind of built up a bit of an intuition for this, so my general rule is if I have any doubt as to whether the part is obviously going to stay on, then I just glue it. But in this case, the heaviest thing we've got here is U12, which you can see under the camera right now. And I'm just going to go check which that is, a 3.3 volt LDO. And so I know that's not going to fall off, and so the 0402s and so on are not going to be a problem whatsoever. So I'm just going to pop over to the other bay here and check whether I have a box here of some really old parts from when I was first starting out and before I had all of my stuff on reels. And one of the reasons I'm using this particular LDO is to use up some of this legacy inventory. Anyway, that's all done. And if anybody is wondering why I'm wearing socks in here, it is both to avoid tracking dirt around into the lab and because the floor of the lab is actually ESD epoxy. It's grounded in 2 points, and as long as I am wearing either ESD shoes or socks, I am grounded and I don't need to worry about wearing a wrist strap or anything. We can actually see, if I just get this one part on here real quick before I explain. If I switch over to this bay here, it is just slightly out of the view of the camera, but you'll probably hear the beep. If I stand here and I push this button here and stand right here, you'll hear the beep from the ESD tester. So that is actually measuring the resistance from my finger to ground while I'm standing on the floor, and it was a little bit fluctuating between in range and a little bit on the high side. It is still a little bit cool in here compared to the summer, and haven't been walking around in the lab too much, and so I'm probably not sweating that much and my feet are a little bit less conductive. But depending on exactly where I am in the lab, it's usually within somewhere in the 1 to 10 megohms to ground from fingertip to anywhere. So let's go back to the assembly view here real quick. All right, and just get all of the 0603s done. Sure with the stream latency in here. Yes, I am on this bench now. Okay, so now we got, looks like 4 of the 1, 2, 3, 4. Actually, no, that is a 2.2, so all of the others are 4.7s. 1, 2, 3. I do have access to a pick and place at a friend's shop, but it takes long enough to get programmed, and also they're not probably awake right now. It is 7:45 in the morning local time, so I'm just going to go do this by hand. And that other 603 is over there. So we got that. Just quickly looking around, making sure I know what we've got. And C31 is also 4.7, so let's get that done real quick. Oh, and then we've got a ferrite. I gotta go grab those. But that is the end of this, except for the 2.2s, which are 2.2, 603. Right, okay. That was actually a last minute design change that I forgot to update the CAD files. That 2.2 should be a 4.7. So I'm just gonna stick a 4.7 on there, and it's fine, it's just decoupling. I'm not super concerned about the exact frequency response of it for this design. All right, so we'll pop that on there and then grab the ferrites, and that is just going to be one of the standard 600 ohm ones I use for general purpose noise filtering if I don't have particularly tight requirements. Okay, so that is the ferret, and I believe that is the last of the 0603s. And then we can go down to the 402s and see. And yes, the interactive bomb has been on my list of things to poke at. I generally, when I'm doing my own designs that I know, it's usually not a big deal, so haven't been too concerned about that. If I am working with other people's designs, that is something that I might have to start thinking about. All right, and then what do we got over here? We got one with no silk screen. That is a 0.47. But yeah, especially with my own designs that I know well, it's usually, I pretty much remember what parts I put everywhere, and I already know what to expect, so These go pretty quickly. Oops, I missed 2 capacitors from the last round. So I'm gonna actually run back and grab those. And then the resistors as well. Just when I thought I got all the 603s, I moved the board, and I've got C5, 8, and 9, which should all be, yep. So we got 3 of these. And again, some of those were supposed to be 2.2s, but I only have those in a different size, and I usually swap those for 603s with, or 4.7s with no L effects. All right, and now we're just about done with everything except we got a few resistors that I gotta go check. All right, so that is a 0.47, as are almost everything under here. C4. That's a 10K, we'll do that later. And I think we're just about done over there. And then we've got, these are 33s. Did I bring those out yet? I did not. 33 is my standard series terminator. As far as keeping track of components, I have definitely at least a few hundred parts in stock. The bins are sorted by category. So I've got, for example, one bin for microcontrollers subdivided. Well, actually, I've got a couple bins for microcontrollers. I've got one for STM32s separated by like L1s and L4s on one side and H7s on the other side. I've got 3 bins for resistor subdivided by decade. So as soon as I get this part placed, I will go show you. So those are the 33s. And so like this one here, for example, I've got, this is capacitors. Yeah, let's just make sure I'm in focus here. And so it's sorted by value, so they're color-coded by type. So I've got, for example, red is passive components. I've got different shades of red for capacitors and resistors. And then they're sorted within each pile. They're sorted numerically. So within this decade, I've got like, this one here is, from here, I believe, is the lowest values going up to the highest values. And then the second row in the back is even higher values. And so then I can just go take out the stack of parts and find what I'm looking for pretty quickly. It is definitely not as fast as some other options, but again, there's trade-offs in terms of packing density and being able to fit a lot of stuff in there and not having to mess around with barcode scanners and things like that, because I'm doing a lot of high mix one-off prototypes and things like that, where if I were to actually do any kind of a computerized inventory system, I would end up spending more time maintaining it than actually using things. So like I've got a rough spreadsheet of some of the bigger, like expensive FPGAs and stuff. I have a pretty good idea of how many of those I've got in stock, but I have no idea how many passives I have in stock. So for the most part, it's just, I know what values I've got. I have a text file of 40402 resistors specifically. I've got a text file listing all of the values that I have, and that is actually used. I've got a little script that I use for voltage divider calculations, so I can go and put in a list of I put in the pre-existing list of all the values that I have, and it knows, I say like, oh, I want to divide by 2 with a string between 100K and 1 meg in value, and it'll go find something that meets that requirement. Or I need R1 to be 6.8 times R2, and it'll go and find something that is as close as possible to that, and it'll tell you the percentage error if it's not exactly satisfiable as is. And so it's a pretty handy little tool that I make heavy use of. All right, so let's put this away and get the other resistors. I am going to have to wrap up the stream pretty soon, even if I don't get everything populated, because my kid is going to be waking up soon and is going to be demanding breakfast and so on, so I may have to finish the board later. But actually, before I get into finishing the rest of the design, I'm just going to quickly test a few of the other camera angles. So when I'm doing some of the inner layer rework, this is roughly what that is going to look like. I may probably try and do a long shot as well, but this is going to be the view from within the machining operations, and so I can move the board around with the mill axes and move it around like that. The nozzle that you see is the nitrogen flood spray to blow away chips. And then this is the actual cutter. Of course, the spindle isn't running right now, but just for testing purposes. So I think that camera position or something pretty close to it should work out decently. And, all right, let's just see how many of these we can get stuffed in the next few minutes. So, R1 is a 33, which I just had here. Yeah, I've tried to make databases for keeping track of inventory in the past. Every time they were like obsolete before I was done populating the database, and I couldn't make it work. So for higher volume stuff, if I was making, 50 of the same board on a pick and place, yeah, it's easy to just go scan the barcode on each reel and have a placement file that has an inventory for each thing. But when I'm doing a lot of stuff by hand, especially on, reworking, when I'm constantly poking things that I had to pick out and be like, oh, I spec this value and I want to swap it to this one, or, oh, I forgot to pull up, I got to go shove a 10K on here that's not in the CAD files, and it just becomes impractical to go try and track that kind of stuff in a database. Okay, and then we have R7 is a 0. I will get that in a little bit. 0, 1206, oh right, my reel of 00402s is MIA, so I gotta grab the one from the other pile. So that was R7 that I was at, and that is to the right. Leave that there. And then up here we've got, that is a 0.47. That is a 33. And then we have a 10K and a 33. R5. Perfect. All right, so now going around here, just making sure I've got everything. I think almost everything left is a 0.47. We've got that, and 1 second. All right, looks like we are going to have to wrap up now, so I will stuff the rest of this off camera and move on to doing the rest later on.